R2.12 on function notation. Function notation is a method for writing the dependent variable to emphasize that it depends on the independent variable. Y equals 3x minus 7 is a function, but right now it's written in equation notation. With the y equals, but we can change it to f of x equals to make it in function notation. It's more descriptive. Tells you right away what the independent variable on the inside is called and what the dependent variable on the outside is called. So we're going to start writing things in function notation, whether we're working with our equations or with our models. We're going to turn them into functions as well. All right. So there's a few notes here. F is the name of the function. That x is not multiplied. It's just the name of the independent variable. It's read as f of x. And we can also use sum and difference notation to write a product or sum or quotient of two functions. So we can write f plus g of x to mean that we're going to add up two functions together. So we have short notations for adding, subtracting, multiplying, and dividing functions as well. Okay, so first of all, we're going to just use function notation to plug in values and solve functions or equations. This is f of negative 1/3, so I'm going to plug negative 1/3 into f. F is 3x plus 5, so that's going to be 3 times negative 1/3 plus 5. 3 times negative 1/3 is negative 1, plus 5 is 4. Okay, or g of negative 4. G is x squared minus 2x minus 6. That's going to be negative 4 squared minus 2 times negative 4 minus 6. Negative 4 squared is 16. Negative 2 times negative 4 is positive 8 minus 6. That would be 16 plus 8 is 24, minus 6 is 18. H of negative 2. The h function is x cubed. So negative 2 cubed, 3 negatives make a negative, negative 8. Now, in part D, I'm going to plug in the expression a minus 2 into f. So that would be 3 times, instead of x, I get the whole expression, a minus 2 plus 5. And then it's an expression now, so I just want to simplify it using the distributive property. And I'll get 3a minus 6 plus 5, combine like terms, 3a minus 1. Part D, find x such that f of x is equal to negative 2.5. So I set the equation f equal to negative 2.5, and then I solve for x. So 3x is equal to negative 7.5, and if we divide both sides by 3, we get negative 7.5 divided by 3 is negative 2.5. Okay. Last, f plus g of 3, so that's adding the two functions together. So I want to take f of 3. F of 3 would be 3 times 3 plus 5. Then I want to add g of 3, which is 3 squared minus 2 times 3 minus 6. Technically, we can group these in parentheses, finish each one separately, then add them up. Although, since they're going to have like terms, it doesn't really matter which order I do it. But I want to add up the two functions evaluated at 3. So that's 9 plus 5 plus 9 minus 6 minus 6. That would be 18, 23 minus 12. Oops. If you add up the positives and the negatives, and then if you subtract, you're back down to 11. Okay. On the next page, we're looking at evaluating functions from a graph. H of negative 2. Negative 2 is an input and x value, so negative 2 hits your graph down here at negative 4. So the output value is negative 4. Find x when h of x equals 5. Now that 5 is a y value, so y value 5 is going to hit down here, x value 4. h of 0, 0 is an x value, outputs 3, negative 3 I meant to say, outputs negative 3. Find x when h of x equals 0, y value 0. There are two places, so there are going to be two answers here. X is going to be negative 6 and 2. The domain, okay, remember that the domain was lowest x to highest x. That's going to be negative 6, this is an interval, comma 4. Range, lowest y to highest y, so that's going to be negative 4, comma 5. Intervals again. We can use a table to evaluate our functions also. So g of 4, 4 is my input, spits out the output 1. G of 0 plus g of 6. G of 0 outputs negative 5. G of 6 outputs 4, so that adds up to negative 1. Find x when g of x equals negative 2. Negative 2 is the output now, so the x value is 2. What type of function does g of x appear to be? I haven't studied it yet, so let's go ahead. If you look at the x's, change in 2, change in 2, change in 2, change in 2. Look at the y's, changes 3, changes 3, 3, 3. It's linear. Explain. Well, you found its slope. So the slope is 3/2. You could even write the equation. So g of x equals 3/2 x plus the y-intercept is negative 5 because the x-coordinate 0 matches with negative 5. But finding the slope is the reason that it's linear. But you can go further and write the equation. Find the x-intercepts and y-intercepts of this function. Okay. For the x-intercept, remember that we want to set y equal to 0. So we'll say 0 output equals negative 3/4 x minus 24. Add the 24 over. 24 equals negative 3/4 x. To divide by a fraction, you multiply by the reciprocal. See, 3 goes into 24 8 times. Negative 4 times 8 is negative 32 equals x. That means that my x-intercept will be negative 32, comma 0. The y-intercept has the x value 0, so I can plug 0 into the function. I'll get 0 minus 24 is negative 24. So the y-intercept, which is your b value, is 0, comma negative 24. Last page. Suppose that P equals f of t represents the number or percentage of U.S. teens who've ever smoked cigarettes in years past 2000 with an R squared of 0.98. So it's a very strong model. Is the relationship direct or inverse? Okay. This is a linear relationship. Linear relationships are direct. Inverse relationships have the variable in the denominator. So a direct relationship would be something like y equals mx plus b. It's a product. And an inverse relationship would be something like y equals a divided by x. So that would be a quotient. Okay, so this one is direct. Because it's a product, right? It's a linear equation. Linear equations are direct models. What is the strength? It is very strong. Very strong because that R squared value is nice and close to 1. You don't need to say very, just strong would suffice. Find f of 18 by hand. F of 18 equals negative 0.64 times 18 plus 14.24. When you think about by hand, it really just means write it by hand, use your calculator. It means don't do it graphically. So negative 0.64 times 18 plus 14.24 gives us 2.72. What does it mean in this situation? When I explain what it means, I have to talk about what the 18 means and the 2.72. 18 is years since my starter. My starter was 2000. So that means in 2018. And then 2.72% of teens reported smoking in the past month. Part D, find T when f of t equals 6. That's an equal 6, so I set my equation equal to 6. 0.64t plus 14.24 equals 6. And like terms, subtract the 14.24 from both sides. Negative 0.64t equals 6 minus 14.24, which is negative 8.24. Divided by negative 0.64. Oops. There we go. So T is 12.875. Don't forget to add your starter year, which was 2000. So now you're looking at 2012.875. It's up to you to interpret that. It's technically still in the year 2012, but it didn't happen for the majority of that year. So oftentimes we'll round that up and say in 2013. What happened? So 6 is their answer. So 6% of teens said they smoked in the past month. So reported smoking in the past month. Okay. Using the regression model, that's the one they were giving us. Find the P-intercept by hand. What does it mean? Okay, so remember I want P-intercept. That's when I want T equals 0. I want the P-intercept, so I'm plugging 0 in. So P of 0 is 14.24. What does it mean? When that T value is 0, that's my starter year. So in 2000, 14.24% of teens reported smoking in the last month. Find the T intercept. So remember that's the P equals 0 piece. This one I don't know. I have to solve for it. So 0 equals negative 0.64 plus 14.24, negative 0.64t plus the 14.24. Add the 0.624t over. Doesn't matter which term I move, but I might as well have all positives if I can. 0.64t equals 14.24 and divide. 14.24 divided by 0.64. So 22.25, that's a T value. T value, so I add my starter back onto it, which was the year 2000. So that's 2022.25. So it's really early in that year, so we're going to go ahead and use that year and say in 2022, 0% of teens reported smoking. That's hopeful. All right, and we're at the end of our section.